The first thing you should do when fitting a pair of progressive lenses is to adjust the frame to the patient's face. It's simple and will ensure that your measurements are accurate so your patient has maximum comfort with their new lenses. First, adjust the nose pad and temple as needed to set the vertex distance to between 12 and 14 millimeters. Will you look to the side for me? Vertex distance is the distance between the front surface of the eye, or the cornea, to the back surface of the lens. Next, adjust the frame's panoscopic tilt. Panoscopic tilt refers to the vertical angle of the lens in the frame and should be between 6 and 8 degrees. Lastly, make sure the frame has a positive wrap angle. Marvin, will you look down for me, please? Wrap angle refers to the degree to which the frame wraps around the wearer's face. The average wrap angle is about 7 degrees. Right, Marvin, how do those feel?
Great.
Good. Measuring pupillary distance, or PD, ensures your patients will get the most accurate prescription in their lenses. For a progressive lens, you should use a monocular pupillary distance to ensure exact centering of the eye behind the lens. The preferred way to measure monocular PD is with a pupillometer. First, set the pupillometer setting to infinity. Then place the brow bar against the patient's forehead, making sure the pupillometer is centered on the patient's face. Hold that like a pair of binoculars. Look into the pupillometer and adjust the vertical bars so the line is bisecting the corneal reflex. The corneal reflex is the reflection on the cornea of the light emitted by the pupillometer. Thank you, Marvin. Then look at the bottom of the instrument and note the monocular PD. In this case, it's 35 millimeters for both eyes. You can also use a PD ruler to measure monocular PD. To measure monocular PD with a PD ruler, place the notch on the bottom edge of the ruler on the bridge of the patient's nose. Then record the monocular PD for each eye using the scale on the bottom of the ruler. In this case, again, the monocular PD for both eyes is 35 millimeters. When taking the fitting height measurement, be sure to situate yourself directly in front of the patient's eyes. Your eyes should be at the same level as the patient. Thank you, Marvin. Mark each lens at center pupil using a felt tip pen. Draw a horizontal line on each lens, making sure the lines cross at the center of each pupil. Measure the fitting height from the deepest point of the lens to the horizontal line. In this case, the fitting height is 26 millimeters. It's that easy. For Xyl frames, remember to measure to the lowest point of the bevel. In most cases, the bevel will be about midway into the body of the frame. Glasses sit on everyone's face differently. Today, many progressive lens designs incorporate personalized measurements to tailor the lenses to the patient's unique facial features. One of these measurements is the frame's panoscopic tilt. Panoscopic tilt is a big term, but it's really very simple. It refers to the vertical angle of the lens in the frame. If you have a measuring device like a VisiOffice or a MyFit, you can use it to measure the panoscopic tilt. If you do not, you could use a measuring tool like this one. First, place the glasses on the patient's face. You look to the side for me, Marvin. Then, position the long end of the tool horizontally next to the frame's temple. Next, swivel the angle of the rounded end of the tool to align with the tilt of the lenses. Optimally, the frame should be adjusted so that the panoscopic tilt measures between 6 and 8 degrees. Everyone's face is different, and the way our glasses sit on our face can affect how we see through the lenses. To accommodate this, many progressive lens designs incorporate personalized measurements like the frame's wrap angle. Wrap angle refers to the degree to which the frame wraps around the wearer's face. If you have a measuring device like a VisiOffice or MyFit, you can use it to measure wrap angle. If not, you can use a chart like this. To measure the wrap angle, place the frames on the chart so the bridge is aligned with the 0-degree line. The wrap angle is measured where the lens ends near the frame hinge. In this case, the wrap angle is 9 degrees. The frame should have a positive wrap angle, meaning the frame should angle in around the patient's face with a measurement above 0 degrees. Everyone wears their glasses differently. To accommodate differences in patients' facial features, many progressive lens designs incorporate personalized measurements, like the vertex distance. Vertex distance is the distance between the front surface of the eye, or the cornea, to the back surface of the lens, and it's really very easy to take this measurement. If you have a measuring device like a VisiOffice or a MyFit, you can use it to measure the vertex distance. If not, you can use a measuring tool like this one. First, place the glasses on the patient's face. You look to the side for me. Place the measuring tool next to the glasses and measure the distance from the front of the eye to the back side of the lens. Optimally, the frame should be adjusted so that the vertex distance measures between 12 and 14 millimeters. In this case, the vertex distance is 12 millimeters. Thank you, Marvin.
You're welcome.
Before placing the order, it's important to make sure the progressive lens you choose for your patient will fit in the frame he or she selects. To check this, you can use a lens cutout chart. First, if it's not already done, dot the lens at center pupil. Place the dot over the cross in the lens cutout chart. Verify the appropriate lens diameter is larger than the lens shape. If it does not fit, ask your patient to choose another frame that will accommodate the lens. Marvin, these look great.
Awesome. Thank you.
We're all done. Once you've received your patient's order back from the lab, you want to make sure the measurements and prescription match what you ordered. Labs sometimes make mistakes, and no one wants to try to put a patient in the wrong prescription. First, you'll want to put a lens mask on each lens. When you get your order back from the lab, usually there are 2 dots on each lens where the microcircles are. If not, you can mark them yourself by holding the lenses up to the light and finding the microcircles. Then, line the dots on the lens mask up with the dots on the lens. First, confirm the pupillary distance and fitting height using a centering chart. Center the glasses face down over the inverted V and place the fitting cross on the horizontal scale. Use the scale to confirm the pupillary distance. For these lenses, the monocular PD was 35 millimeters for both right and left eyes. And as you can see, the fitting cross is at 35 millimeters, so the PD is correct. Next, confirm the fitting height using the scale below the glasses. For Xyle frames, remember to measure to the lowest point of the bevel. In most cases, this will be about midway into the body of the frame. The fitting height for this patient was 26 millimeters. The fitting cross is 26 millimeters from the bottom of the lens for both the left and right side. Next, confirm the distance power and prism using a lensometer. For instructions on how to use your lensometer, you should refer to the manufacturer's user's manual. However, I can show you where on the lens you should confirm these measurements. The distance power should be measured in the distance verification circle located above the fitting cross. The prism should be measured at the prism reference point located between the horizontal markings about 4 millimeters below the fitting cross. Next, verify that the prescribed add power is correct. Hold the lens up to the light and locate the add engraving, located under the temporal microcircle. The add engraving shows the abbreviated add power in the lens. The abbreviated add power is the first 2 digits of the actual add power to the nearest quarter diopter. For example, an add engraving of 1.7 is equal to 1.75. And finally, verify the lens design is the one you ordered. Every progressive lens has a unique design engraving under the nasal microcircle. Holding the lens up to the light, find the lens engraving and verify it is the lens you ordered. Once you've confirmed the measurements, prescription, and lens design, the glasses are ready to be fitted on the patient. Before fitting the patient in his new glasses, you may need to recreate the fitting cross. It's easy to do, and it will help you when you fit the lenses to the patient. To do this, first hold the glasses up to the light and mark the 4 microcircles with a felt tip pen. Next, you'll need a cutout chart like this one. Lay the glasses over the cutout chart and align your microcircles to the microcircles on the chart. Then, mark the fitting cross with your pen. Easy as that. Now the glasses are ready to be fitted to your patient. Today, many progressive lens designs incorporate personalized measurements to tailor the lenses to the patient's face. However, when verifying personalized lenses with a lensometer, the values will be different from what was prescribed. To account for this, labs include a dual pack slip like this one. The dual pack slip shows both the original prescription and the compensated values. You should verify the compensated values with a lensometer to ensure the patient receives the prescription you ordered. It will make sure that your patient gets the right fit, and it will make you look good in the process. First, verify that the original prescription is what you ordered. Then, verify the compensated values in the RX and lensometer section with a lensometer like you would with any prescription. And be sure to apply the same ANSI standards for sphere, cylinder, and axis to the compensated values. Once you've verified the prescription is correct, you're ready to fit the glasses on the patient. With the lenses marked or using lens masks, place the glasses on the patient's face. Make sure the fitting cross is at center pupil. If the fitting cross is not at center pupil, adjust the frames to raise or lower the fit until the fitting cross is at center pupil. If the lenses you ordered incorporate personalized measurements like pantoscopic tilt, look to the side for me, vertex distance, and wrap angle, look down for me, Marvin. Be sure to recheck these measurements. Thank you, Marvin. Taking these simple steps will give your patients the best fit. How do they feel? Once you fit the glasses to the patient's face, you can demonstrate the viewing areas using a reading card. First, demonstrate the reading area. Ask the patient to hold the card at a comfortable reading distance about 16 inches away from his face and have him read the print.
Nice.
Next, have the patient hold the reading card at arm's length and ask him to read it through the intermediate portion of the lens to demonstrate the intermediate viewing area.
I like that.
Now, will you look at something in the distance for me? Ask your patient to focus on something at least 20 feet away through the distance portion of the lens to demonstrate the distance prescription.
Looks great.
Finally, have the patient shift his vision from distance back to the reading card in the intermediate zone to demonstrate the smooth transitions as they shift focus.
Great.
Good.
Thank you.
Thank you, Marvin. Often, glasses need to be adjusted to make sure the lenses are working as well as possible for the patient. You can use these steps to correct common fitting issues. If the patient has a narrow reading area, first, verify the fitting height and PD measurements are correct. Then, verify that the add power is correct. If the fitting height, PD, and add power are all correct, add panoscopic tilt and decrease vertex distance. If the patient complains that their peripheral vision is blurry and warped, adjust the frame to decrease vertex distance and increase the wrap angle. If the patient lifts his head to read or lifts his glasses to read, the lenses are fit too low. Adjust the frame so that they sit higher on the patient's face. You can do this by adjusting the nose pads closer together. You can also try decreasing the panoscopic tilt. If necessary, refit the lenses. Conversely, if the patient lowers his head or glasses to read, the glasses are fit too high. Adjust the frames as needed. If the frame has nose pads, widen them to lower the frame. You can also try increasing the panoscopic tilt. If necessary, refit the lenses. If you notice the patient moving reading material to the side for better focus, the PD is off or the lenses may not be mounted correctly. First, use a lens mask to verify the lenses are on axis, meaning the microcircles all form a straight horizontal line across the lens. Next, verify the monocular PD measurements are correct. If these measurements are correct, have the lenses remade with the correct PD measurements. If the patient's distance vision is slightly blurry, increase the panoscopic tilt or slightly decrease the lens fitting height.